module we are going to discuss about types of analysis. So, the outline of this module is classification according to the force analysis, classification of analysis according to how the force is acting, and classification of analysis according to the behavior of material, and then classification of analysis according to the level of deformation. So, these three classifications we will discuss in this module. So, now if we look at the vibration, so vibration is an oscillatory motion. So, something like simple harmonic motion, if I pull the pendulum and leave it, so it is set to vibrate. So, this is called simple harmonic motion. So, this kind of motions we see in our day to day life. So, while we walk, we do to and fro motion of our hands, so our heart beats, so many things, our legs are in rhythm. So, what we are trying to do is we are balancing ourselves. So, this vibrations, its effects are very common in our daily life. So, if you look at the existence of human life, it completely depends on say vibration. So, for example, heartbeat. So, heartbeat is a vibration. So, it is continuously happening, and we cannot hear, we cannot speak, and we cannot express without vibration. So, vibration is most essential part of our life. Not only we human beings, all around us are also dependent on vibration. Okay. So, for example, the universe around us is governed by a definite principles. So, there is periodic motion. So, day and night, all these things are anyway happening. If you look at it, we will understand. Now, why its study is important, especially for us civil engineers. So, it is important for us because like these days tall structures are coming, daring structures are coming, and there is a possibility that these structures are subjected to like severe vibrations. So, in normal structures also sometimes when machines are installed, so they are set to vibrate. So, we need to study the dynamics of the floor on which machine is installed. So, that is floor vibration. So, because of that, whether floor is safe or not, so we need to understand what is the relationship between that floor properties and the machine properties. So, is RPM is proper or not, and then a tall building, so which is subjected to wind vibrations. So, that is also oscillatory motion, that also we need to understand, and sometimes this building is subjected to earthquake ground motion. So, that is also vibration. So, that also we need to understand. So, it is very important for us to understand the dynamics of structure when it is subjected to force. So, now classification of analysis according to force. So, we have two kinds of analysis, one is called static analysis and another one is dynamic analysis. So, what is static analysis? Static analysis is in which you can see this example. So, there is a cantilever and force is acting at the tip of the cantilever. So, because of the application of this force, the member, that cantilever beam deflects, and if you increase the load, more will be deflection. If you further increase the load, more will be deflection. But whatever amount of load you kept, deflection will be constant there. Deflection is not varying. So, as long as applied force is constant, the response of the structure, that is displacement, is constant because stiffness is a fixed quantity. And in this the next one, dynamic analysis. So, in dynamic analysis, what is happening is force is varying. So, you can see here the difference between force here and difference between force here. In fact, it should be written arrow up and down, up and down. So, this is going means increasing, decreasing, increasing, decreasing. So, how it is governed? You can see applied force is dynamic. So, that means it is the force is not constant, force is varying in time. So, as you can see this one, so on x axis it is time scale and on y axis it is the amplitude of the force. So, this force is continuously varying. So, it can be as random as possible, but it is varying with time. So, the analysis in which force is considered as a varying force, that goes into dynamic analysis. The analysis in which force is static or constant, that is called static analysis. So, this is a classification of analysis according to the force type or type of force. Now, the next one is classification of analysis according to the behavior of the material. So, in this we can classify it in two parts, that is linear analysis. So, in linear analysis, once again we discuss with this example. So, cantilever beam, force is applied. So, loads are well within the elastic deformation range. So, loads are well within elastic deformation range means what? So, material obeys Hooke's law. Material obeys Hooke's law. So, Hooke's law means stress is proportional to strain, and then superposition principle is applicable. So, the superposition principle is applicable means, like there is a cantilever beam and I apply say 1 kilonewton load here and it deflects, and then I apply say another 1 kilonewton load, it deflects. So, if I add 1 kilonewton load deflection and second 1 kilonewton load deflection, so the addition of that will be equal to, if I put 2 kilonewton load, then the addition will be same as 1 kilonewton load deflection plus 1 kilonewton load deflection, or you put 1 kilonewton load at the beginning and then after that remove that 1 kilonewton load, add 2 kilonewton, put 2 kilonewton load. So, deflection due to 1 kilonewton load plus deflection due to 2 kilonewton load, that will be equal to, if you put 3 kilonewton, that will be equal to deflection due to 1 kilonewton load plus deflection due to 2 kilonewton load. So, that means when both are same, we say that superposition principle is applicable. Now, you can see this plot where displacement is on x axis and load is on y axis. This is linearly proportional. So, force and displacement are proportional with some constant term. That constant term, the slope of this line is called as stiffness of the system. P is equal to Ku, or we can also derive from this one, that is U is equal to PL cube by 3EI. So, if you want to write the same displacement relationship in the deflection relationship in this form, so that will be equal to P is equal to 3EI by L cube into U. This is the relationship in this one. So, here we can see that up to this point that load is proportional, load and displacement are proportional, or stiffness is constant. So, that we call it as linear analysis. Analysis well within the limit of this proportionality goes into linear analysis. Now, the next analysis is nonlinear analysis. This is dependent on the nonlinearity of the material. So, the same thing, cantilever beam, point load applied at the end. So, in this one, loads are beyond elastic range of deformation. So, for example, in this case, say if deflection of the beam when some force is applied is say 0.1 millimeter, 0.1 millimeter, say length of the beam, let us say an example, say 2 meters. So, if we apply say 10 times P, then the deflection will become 1 millimeter, and if we increase the load and further and apply, then the 10 times more, so 100 P, then deflection will become 10 millimeter, and if we further apply, increase the load and go further, then it becomes 100 millimeters or maybe 1000 millimeters. So, 1000 millimeters means it is equal to nearly half the length of the beam. So, what happens is, before it is reaching this 1000 millimeter, usually it fails. If I go on increasing the load here, so that will not be any more linearly proportional, it will break at some point. So, where it will yield, where the first crack comes, so from that point onwards, this linear analysis is not applicable and the superposition principle is not applicable. So, that is where this nonlinear analysis comes, that is loads are beyond elastic range of deformation. So, then this equation P is equal to Ku will not hold good in its form. So, some changes are needed. So, what changes are needed? The changes are stiffness is dependent on deformation multiplied by deformation. So superposition principle is not applicable. Okay. So you can see this graph. So in horizontal axis is displacement, vertical axis is load. It is proportional only up to this level. So this we can call as yield force or yield displacement, uy. So up to that this linear analysis is applicable, and beyond that it is non-linear analysis. As you can see, after yield, tangent of that, the slope of the tangent at every point is reducing. So that is considered in non-linear analysis. And the next classification of analysis based on the range of the deformation. So even in non-linear deformation, non-linear analysis, so it can say member is cracking, member is deflecting, member is cracking, but member is not collapsing, member is not collapsing. So that means what? The deformation of the member is within the limits of allowable deformation. So that we call it as small deformation analysis. So analysis is confined to primary effects in that, and we consider only material nonlinearity in it. And then in large deformation, so analysis considers secondary effects also. So that means what? Secondary effects include like P delta effects and buckling effects, those things are considered. So here geometric nonlinearity is also included in this analysis. So it will be slightly complicated, like time involving process in this large deformation analysis. The small deformation analysis consists of linear, non-linear, static, dynamic, small deformation analysis theory, and in large deformations usually non-linear, static and dynamic analysis will be there in large deformation analysis. Total 6 types of analysis are there. That. So in summary, in this module we have discussed classification of analysis based on force type, based on the material, and based on the deformation range. So we have discussed static analysis and dynamic analysis. Dynamic analysis where force is a function of time, static analysis where force is constant, and the second classification is linear analysis and non-linear analysis. So linear analysis is like the deformation is up to a stage, up to a point where Hooke's law is applicable, and non-linear analysis is beyond that point. And then the third classification is classification based on the range of the deformation, that is small deformation analysis and large deformation analysis. So usually small deformation analysis primary effects are taken into consideration, and large deformation analysis secondary effects are also taken into consideration. So like say collapse analysis of building, and like progressive collapse, breaking of some elements in building. So all those things come under large deformation analysis.